Hey everybody! So we're going to be looking at 6A in our AKS portfolio today. 6A says, I can develop and use models to explain the properties of solutions. So the very first thing on your AKS portfolio looks something like this. You have your very first model. It says label the model with the following words: solution, solute, solvent. Now, I want to remind you really quickly, in the past we've learned about solubility, and solubility is just the ability for something to dissolve, okay? So we're talking about creating a solution now. When we create a solution, we are going to dissolve a substance into a new substance, mix it together, stir it, heat it, okay, until it's dissolved, and it will become a solution. So in this case, when you're looking at this model, we have one substance. We can just pretend this is Kool-Aid powder, okay? So Kool-Aid powder being put into another substance, in this case it's water. And then once it's stirred around and dissolved thoroughly, we end up with what we call a solution, okay? So in this case, our Kool-Aid powder would be the solute that we're going to put into our solvent, water. The universal solvent is water, H2O. So if you're ever thinking, I can't remember which is which, water is most likely always going to be your solvent. It doesn't have to be. There are lots of other things that can also be your solvent, but the universal one is always going to be water, okay? So as you increase the solvent, you decrease the concentration, okay? So concentration is how much proportion-wise you have solute in your solvent. And I'm going to show you a diagram in just a second that makes this more visually understandable, okay? So as you increase the solute, the solution becomes more concentrated. And if you think about this as Kool-Aid, if you just add like, a teeny tiny bit of Kool-Aid powder and you stir it around and you see that it's very light in color, it's hardly changed, it kind of just looks like water still. When you taste it, it's like slightly flavored. That's very diluted, okay? But if you keep pouring more and more solute, that Kool-Aid powder, into the water and stirring it up to create the solution, you're making it more and more concentrated. So if you were to do something like, I don't know, throw the whole thing of Kool-Aid powder in your cup and stir it up, you just added so much solute to your solvent, you created a very concentrated solution, okay? Next one, draw models of the solution in the beakers gaining concentration. So you have 3 beakers. The first beaker needs to be diluted, the second one needs to be gaining concentration, and the third one needs to be the most concentrated out of all of them. It says on your paper you can do the solvent particles represented with circles and the solute represented with an X. If you have colors at home, feel free to use colors instead, okay? So this is what mine looks like. And you can see my first one, the bluish green dots are the solvent. So we can kind of pretend, hey, this is water, right? The universal solvent's water, so that's a good example of that. We can say Kool-Aid powder is these red dots. So in this first one, I've just put like a little pinch, just a little pinch of Kool-Aid powder in there. It's dissolved, it's created a solution, it's just very diluted. The second one, and this one would kind of look like this, okay? The second one here, maybe I put in like a spoonful of my solute, which would be my Kool-Aid powder, stirred it up, fully dissolved it, and maybe that's kind of in between here, right? When I see this in real life, my model is showing you that I only have a little bit of solute mixed in, all right? And then my last one, you can see that I have a whole lot more red dots going on, so my solute has increased. With increased solute means I'm increasing my concentration. So maybe this one is around this section right here. This one right here, it would be highly concentrated. I would have a lot of red dots going on in my solvent proportion wise to each other, okay? So this one says complete the model of salt NaCl and sugar C12H22O11 solution showing its conductivity. So before we even get into this, let's remember about ionic and covalent bonds and which ones are conductive. So do we remember that ionic bonds are formed between metals and nonmetals? In this case, salt NaCl is an ionic bond. Na is sodium, Cl is chlorine. Sodium is a metal, chlorine is a nonmetal. So salt will be conductive because sodium is a metal. Remember, metals are conductive. This is going to have ions in it, okay? It is an ionic compound. And then sugar, carbon, hydrogen, oxygen, those are all nonmetals. And nonmetals do not have conductive properties. So this one, just going off a prediction, we could say, oh, we predict this one will conduct electricity because it's ionic, and this one will not because it's covalent. And indeed, that's true. So what I would need to do to test this out, I would need to fill my beakers with water. Okay, I would need to create a solution. So I could have one of my beakers with salt, put the salt in, stir it, mix it, heat it, whatever you got to do to get it to dissolve. Next beaker, the same thing, but with sugar. Add your sugar, stir it, heat it, mix it, whatever you got to do to make it a solution, right? Then put your wires or probes in. You can see I just kind of drew a little picture of it for you. And once it's in, like my water, it's so awesome. And then this is my solution that I've already mixed the salt in, right? It will light up this light bulb because it is conductive. Remember, there's going to be ions in here, okay? And then this is my sugar. Hopefully you can see it behind my face. But the sugar has no ions going on in my solution. Therefore, there will be no transfer of electricity, okay? So my light bulb will not light up. And this concludes 6A. So if you have any more questions, please let me know. Thanks, guys. Bye.